and Namaste. Welcome back to my channel GeoinfoNepal. Today I am going to calculate the landslide susceptibility using weight of evidence model. This is the step-by-step calculation part, and I have used ArcGIS to prepare landslide susceptibility map. Although this is the demo for landslide susceptibility map, so I have only used two parameters. For your better result, you have to use more parameter which is directly affected by a landslide. To do this, you can use more article about landslide susceptibility model. So without any delay, I'm going to enter the calculation part here. At first, I have used only two parameters which I have shown in this window. This is landslide parameter and then this is slope parameter. In slope, I have classified it in 4 parts. That means this is 32 above. Sorry, there is a mistake on level. There is landslide, which is categorized by 7 subcategories, and slope, which is categorized by 4 subcategories. Okay. After completion of this step, let us consider my total area is 1000 km square, and then in 1000 km square there is 100 km square total landslide area. So in this demo I have used the calculation part of slope. At first you have to understand the area, understand the concept of these subclass areas. So here, okay, now we move for further step. Second step is calculate the weight of its factors and sub-factors. So step 1, there is the calculate the prior probability, which is indicated by PL. PL means the ratio of total landslide area, which is divided by total area. The total landslide area means 100 km square, and then total area is 1000 km square, altogether is 0.1. Similarly, in step 2.2, this is the calculate the class-wise probabilities. That means for class 1, 2, 3, and then 4. At first, we have to calculate the probability of each slope class. That means the probability of total areas of class 1 and then total areas of study area. That means the total area of study area is 1000 and then total area of class 1 is 200. So 200 divided by 1000, which gives 0.2 value. Similarly, we have to calculate the probability of landslide occurring within each slope class. That means within 10 degree, within 20 degree, within 30 degree, and within 30 or above degree. So here you can see the probability of landslide occurring in slope 1 is the total area of 200, which is in denominator, and numerator for area 10. That means 10 divided by 200. 10 divided by 200, that which gives the result of 0.05. And the probability of no landslide occurring within this slope is 1 minus this PLS value. PLS I means number of classes. That means 1 minus 0.05, it gives the result of 0.95. Similarly, for class 2, we get the probability of its slope class is 0.3. Probability of landslide occurring within class 2 is 0.067, and probability of no landslide occurring in this class 2 is 0.933, which means 1 minus 0.067 gives result 0.933. Okay. Okay, for class 3, probability of total overall probability of class 3 is 300 divided by overall area gives result 0.3. Probability of landslide occurring means 0.133, and probability of no landslide occurring in this class is 1 minus 0.133 gives 0.867. Similarly for 4. After that, we have to calculate the weight for each class. So there is a positive weight of evidence and negative weight of evidence. The formula of positive weight of evidence is a logarithm of probability of landslide occurring in this class divided by total probability of that area. That means PL. PL means this. Total landslide area divided by total area means 0.1. So this is positive weight. And the negative means the no occurring in this class means the logarithm of probability of no occurring landslide in this area divided by total probability or prior year probability in this area, that means 0.1. So where the no landslide occurring areas means 1 minus landslide occurring areas. We understood in this part. Now for slope 1, sorry, class 1, that means within. So for second class, we got this result, and all result is obtained using this step. So summary of weight, that means the for within 10 degree we got positive value weight and negative value weight, and weight of contrast means the positive weight minus the negative weight. That means minus 0.0693 minus 0.054 gives the minus 0.747 value. So it indicates that the more weight of contrast in this class means the higher susceptible areas of that class. That means the more weight of contrast lies in fourth class. That means 30 to above. So we got the more susceptible area in this class. Okay, now I am going to combine this weight. So for landslide susceptibility for a specific location, the weights for all the conditioning factors, including slope and many more factors are combined. Okay, here the total weight for a location within given slope class is corresponding to positive weight of evidence for that class. I already said that 0.463 is the greater weight of contrast in this case. So the landslide occurring is more in this class as compared to others. So for the example calculations for a location within the 30 to 40 degree slope class, total weight is 0.405. So the positive weight indicates the higher susceptibility to landslide for area within the slope, this range. Okay, now all the rasters map which is prepared on the basis of factor So uh, there is the mistake. I only use two causative factors. So these factors were prepared using weights of contrast value, which were then integrate using raster calculator for the spatial analysis tool in ArcGIS to produce the landslide susceptibility index (LSI). The final landslide susceptibility index map were prepared based on the equation. Sorry, there is a mistake. Uh, I followed an article, so this is copied from article. Okay, LSI means this total combined weight. That's mean the weight of contrast of each factor. That means slope, aspect, if you have curvature, if you have, and many more. I only use slope and is in this case. So the meaning of weightage and positive weightage and negative weightage in landslide susceptibility. You have to clear that the negative weight indicates the occurrence of landslide is less likely in that particular slope. That means no landslide pixel occur in that class. And the positive weight indicates the occurrence of landslide is more likely in that particular class. For example, in that particular slope class as compared to the overall average probability of that landslide in this area. This means that the conditions in the slope class are more favorable for landslide. Here, this means that the conditions of slope class are less favorable for landslide. That means if the negative weightage is stronger than positive weightage, then there is the less favorable chance for landslide. If the positive weightage is greater than the negative weightage, then there is more favorable for landslide. Why only consider the positive weightage for higher susceptibility? We consider the positive weightage to indicate the higher susceptibility because the positive value signifies the increased probability for landslide in that slope class, which is relative to the baseline probability. So this helps in the identifying the areas that are more prone to landslide and requires more attention for mitigations effort. Okay, this much for calculation part. Okay, in map making section, I have used ArcGIS medium. I have used two category, two parameters. At first, I have to use land code, but it is in vector format. So I have changed land cover to by curvature. So let's talk about slope. Now I am going to reclassify slope in four classes: 10, 20, 40, and then above. In this case, the weight of contrast is 0.4747, so I am using the 10th, 100th position value. You need 100th position value by multiplying by 1000 and use third value, that means 7 minus 7, then minus 4, that means calculate this value is multiplied by 1000, that and use this 100th position value minus 7. We neglect this unit in 10th position. Okay, use minus 7 here and minus 4, 3 and 4. Okay, use the default storage position. And similarly for reclassify curvature, I have to use three classes, that means flat, concave and convex surface. And similarly, by using this calculation, we have to calculate the summary of weight for curvature class, that means for concave, for flat and for convex. For example, I have used here, that means the more negative value, 44 to 40, 75, so one is okay, minus, sorry, plus 6 here. In flat surface there is the no probability of landslide, so I have to use only 1 here, or minus 1 or 0, you can say any value. And here you can use the minus, oh sorry, plus 7, it is more probability for landslide. This is my arbitrary value. You can calculate in similar way of this document I have uploaded in document description section. Okay. This is reclassified curvature, this is reclassified slope. Now we have to calculate the weight in this spatial analyst tool. There is map algebra and inside map algebra there is raster calculator. So here you can use reclass curvature, which is multiplied by sum of weight of evidence, let's say 0.2, plus reclassified slope, which is multiplied by sum of weight of this 7 plus this, sorry, minus 0.0397 spell, which is this is the arbitrary value. Okay, this is final map. Here the white portion shows no probability for landslide, and then dark portion shows the higher probability for landslide. So I have to use this. But it okay, this red person shows the higher susceptibility for landslide, and green person shows the lower susceptibility for landslide. This is not so accurate because I only consider two parameters, and among these two parameters only slope is classified according to this formula, and I also I use the arbitrary value for the curvature class, so this is very low inaccuracy. In this way, you can calculate the weight of evidence and use the weight of evidence model to prepare landslide susceptibility map and many more. Thank you for watching. Please do like, share and subscribe my channel.